Welcome. Our work is entitled Tribological Performance and Corrosion Behavior of Cobalt-Chromium Molybdenum Alloy. This paper investigates the influence of the sintering temperature on the tribological and electrochemical properties of the cobalt-chromium molybdenum alloy elaborated by powder metallurgy and used as implant material. The chemical composition of the initial powders are given in Table 1. For this work, we employed different experimental techniques such as X-ray diffraction, mechanical characterization, and finally, tribological and electrochemical tests. In terms of the obtained results, Figure 2 depicts the X-ray diffraction patterns of the samples sintered at different temperatures. Also, some micrographs of these samples are given in Figure 3. And the following table lists the experimental density, porosity, and microhardness of the ternary alloy at the chosen temperatures. For tribological behavior, Figure 4 illustrates the evolution of the coefficient of friction and the average friction coefficients. However, the evolution of the wear rate versus the temperature is plotted in Figure 5. Also, Figure 7 presents 3D images of the worn surface, and the same micrographs of these alloys are given in Figure 8. On the other hand, Figure 9 illustrates the electrochemical curve in Hanks solution, and the corrosion parameters obtained from the corrosion tests are grouped in Table 5. Also, Table 6 presents the electrical parameters of the equivalent circuit. The Nyquist diagram and the equivalent electrical circuit used for the simulation of the impedance data are shown in Figure 10. The main conclusions are as follows. Higher densification was obtained at the highest sintering temperature of 1300 Celsius degrees. Also, the samples sintered at this temperature exhibited better wear resistance. In terms of electrochemical behavior, the samples sintered at the highest temperature of 1300 Celsius degrees displayed the highest corrosion resistance compared to samples sintered at 1200 and 1250 Celsius degrees respectively. The results of the electrochemical impedance tests in the Hanks solution confirmed the capacitive behavior of the alloy by the formation of a film composed of two layers, a compact inner layer and another porous outer one. On the other hand, the samples sintered at 1300 Celsius degrees yielded the best performance in terms of tribological and electrochemical behavior. And finally, we conclude that the assessment of the effect of the sintering temperature is a key element for the alloy development. Thank you for your attention.